You have a dataset with missing values in a numerical column. Which scikit-learn imputer is most suitable for replacing these missing values with a mean of the non-missing values in that column? A. KNN imputer. B. Simple imputer. C. Iterative imputer. D. All of the above. A. KNN imputer. KNN imputer is used for imputing missing values by considering the nearest neighbors of a data point. It's more suitable for handling complex relationships and nonlinear patterns in data, not just replacing with simple mean values. False. B. Simple imputer. Simple imputer is the most appropriate choice for replacing missing values with the mean or other statistics of the column. It offers a straightforward approach and is commonly used for basic imputation. True. C. Iterative imputer. Iterative imputer uses a model like a linear regression to predict the missing values. It is more complex and generally used for situations where the missing values might have complex relationships with other features. False. D. All of the above. While all these imputers can handle missing values, only simple imputer is specifically designed for replacing missing values with the mean or other statistics of the column. False. B. Simple imputer. Simple imputer is the most appropriate choice for replacing missing values with the mean or other statistics of the column. It offers a straightforward approach and is commonly used for basic imputation. Imputation. The process of replacing missing values in a dataset with estimated values. Simple imputer. A scikit-learn class for replacing missing values with a specified strategy mean, median, most frequent, or a constant value. Mean, median, most frequent. Common strategies used by simple imputer to fill missing values. Fit method. Calculates the mean or other statistics from the non-missing values in the dataset. Transform method. Applies the calculated mean or other statistics to replace missing values in the dataset. Code example. Demonstrates how to use simple imputer to replace missing values in a pandas data frame. Python. From sklearn, impute import simple imputer. Import pandas as PD. Data age 25, 30, none, 35, income 50,000, 6000, 7000, none. DFPD. Data frame data. Imputer simple imputer strategy mean. DFAGE imputer. Fit transformed phage. DF income imputer. Fit transform def income. Print DF. Age income. 025.0 50,000.0. 130.0 60,000.0. 230.0 70,000.0. 335.0 60,000.0. Filling missing values in numerical datasets with the mean, median, or most frequent value. For example, in a dataset of customer information, if there are missing values in the age column, we can use simple imputer to replace them with the mean age of all existing customers. Preprocessing data for machine learning models that cannot handle missing values. Many machine learning algorithms require complete data without missing values. Simple imputer allows us to prepare the data before feeding it into these models. Which statement is true about the scikit-learn iterative imputer? A. It uses a single model to impute all missing values. B. It can handle both numerical and categorical features. C. It iteratively learns relationships between features to impute missing values. D. All of the above. A. It uses a single model to impute all missing values. False. Iterative imputer doesn't use a single model. Instead, it iteratively learns relationships between features and utilizes a model, e.g. Bayesian-rich to predict missing values based on these relationships. Each feature's missing value is imputed through multiple iterations, leading to a more comprehensive approach than a single model-based solution. B. It can handle both numerical and categorical features. True. Iterative imputer is versatile enough to manage both numerical and categorical features. Its strength lies in understanding the interdependencies within the dataset, allowing it to impute missing values for both types of features. This makes it highly valuable for real-world datasets that often contain a mix of data types. C. It iteratively learns relationships between features to impute missing values. True. This is a core principle of iterative imputer. It's not a simple replacement like mean or median imputation. Iterative imputer iteratively refines its predictions for missing values by learning relationships between features. This process is repeated until convergence, ensuring the imputed values are based on a sophisticated understanding of the data's structure. D. All of the above. True. This choice is correct as all the statements in options A, B, and C are true. Iterative imputer utilizes a model to learn dependencies between features, can handle both numerical and categorical data, and iteratively refines its predictions. Its versatility and capability to capture complex relationships make it a powerful tool for dealing with missing data. D. All of the above. Iterative imputation, a technique for handling missing values in datasets by iteratively learning relationships between features and using a model to predict missing values based on these relationships. Predicting missing customer spending data in e-commerce platforms based on previous purchase history and demographic information. Imputing missing sensor readings in industrial machinery to monitor performance and detect anomalies. Filling missing weather data in climate research to analyze long-term trends and model future scenarios. 25, 30, none, 40, 5000, 6000, 7000, none. Bachelors, masters, bachelors, none. A dataset with missing values in age, income, and education columns. Iterative imputer can learn the relationship between these features and impute the missing values. Based on this relationship, missing value imputation, the process of replacing missing values in a dataset with estimated values. Ensuring data integrity in medical records by imputing missing medical parameters for accurate diagnosis and treatment. Completing financial datasets for investment analysis and risk assessment by imputing missing financial indicators. Filling missing information in customer surveys to analyze customer preferences and market trends. 170, 180, none. 190, 70, 80, 90, none. A dataset with missing values in height and weight columns. Mean or median imputation can be used to replace the missing values with the average or central value of the respective columns. Data cleaning, the process of preparing data for analysis and modeling. Ensuring accuracy in machine learning models by removing duplicate records and irrelevant information. Preparing data for data visualization by handling outliers and transforming data for easier understanding. Cleaning data for reporting and analysis to ensure data quality and reliability. 100, 200, 300, 1000, 50, 100. 150, 500, a dataset with potential outliers in sales and cost columns. Data cleaning can involve identifying and removing these outliers to improve the accuracy of analysis and modeling. What is missing indicator? A. An imputation technique that replaces missing values with the mean, median, or mode. B. A transformer that adds binary feature indicating whether a value was missing or not. C. A method to encode categorical features using one-hot encoding. D. All of the above. Incorrect. This describes imputation techniques, not missing indicator. Missing indicator adds a new feature indicating missing values, not replacing them. Imputation. Correct. Missing indicator is a transformer in scikit-learn that adds a binary feature for each original feature, indicating whether the value was missing 1 or present 0. Scikit-learn's missing indicator. Incorrect. This describes one-hot encoding, a technique used for encoding categorical features, not for handling missing values. Missing indicator focuses specifically on missing values. Feature engineering. Incorrect. Only choice B is correct. Choices A and C describe other techniques for handling missing values and feature encoding, respectively. Missing indicator. B. A transformer that adds binary feature indicating whether a value was missing or not. This refers to the techniques and strategies used to address missing values in datasets. Missing data can occur due to various reasons like data entry errors, incomplete surveys, or technical glitches. Imputation is a common technique used to replace missing values with estimated values. It involves filling in the missing data points using various methods like mean, median, mode, or more sophisticated techniques based on the data distribution. Feature engineering is the process of creating new, potentially more informative features from existing ones. This can enhance the performance of machine learning models by making the data more meaningful and relevant to the task at hand. Missing indicator is a feature engineering technique that captures the presence or absence of missing values. Model selection involves choosing the most appropriate machine learning model for a given task. Missing indicator can be used to evaluate different imputation techniques by comparing their performance with and without the generated missing value indicators. Data preprocessing encompasses all the transformations and preparations applied to raw data before feeding it into a machine learning model. This includes handling missing values, scaling features, encoding categorical variables, and removing outliers. Machine learning is a field of computer science that involves the development of algorithms and models that can learn from data and make predictions or decisions without explicit programming. In machine learning, transformers are classes or functions that transform data in a specific way. They can be used for feature extraction, dimensionality reduction, encoding, or other data manipulations. Scikit-learn is a popular Python library for machine learning that provides tools for data analysis, data mining, and model building. It includes a wide range of algorithms, transformers, and utilities for various machine learning tasks. Let's consider a dataset about student performance with features like age, GPA, and attendance. If some students have missing attendance data, the missing indicator would add a new feature called attendance missing with values 1 missing or 0 present for each student. From sklearn, impute import missing indicator, me missing indicator, x transformed me, phi transform x. Which of the following statements about KNN imputer in scikit-learn are true? Choose all that apply. A. KNN imputer replaces missing values with the average of the k nearest neighbors. B. KNN imputer uses Euclidean distance to find the nearest neighbors by default. C. KNN imputer can handle missing values in both numerical and categorical features. D. All of the above. A. KNN imputer replaces missing values with the average of the k nearest neighbors. Correct KNN imputer replaces missing values by calculating the average of the corresponding values in its nearest neighbors. This is its core principle. Example: suppose you have a dataset with age and income, and a missing income value for someone aged 30. KNN imputer would find the k closest individuals based on age. Let's say K3, and their incomes are 50,000, 60,000, and 70,000. KNN imputer would then replace the missing income for the 30-year-old with the average of these, which is 60,000. KNN imputer is a powerful technique in scikit-learn for addressing missing values in datasets. B. KNN imputer uses Euclidean distance to find the nearest neighbors by default. Correct. By default, KNN imputer utilizes the Euclidean distance metric to identify the nearest neighbors. Euclidean distance is a widely used metric for numerical data. Example: imagine you have two data points 1, 2 and 3, 4. Their Euclidean distance is calculated as SQRT 3, 1, 2, 4, 2, 2 SQRT 8, 2.83. It works by identifying the k nearest neighbors based on specified distance metrics for each instance with a missing value. C. KNN imputer can handle missing values in both numerical and categorical features. Correct. KNN imputer is versatile and can handle missing values in both numerical and categorical features. For categorical features, it uses a suitable distance metric such as the Hamming distance. The missing value is then replaced by the average of the corresponding values in its nearest neighbors. D. All of the above. Correct. As demonstrated above, all the choices A, B, and C are true statements regarding KNN imputer in scikit-learn. All of the above statements are true about KNN imputer. D. All of the above. Missing value imputation. The process of replacing missing values in a dataset with estimated values. Enabling complete data for analysis and modeling. Data preprocessing. Transforming raw data into a format suitable for analysis or modeling. Often involving tasks like missing value imputation, feature scaling, and encoding categorical variables. Machine learning. A field of computer science focused on enabling computers to learn from data without explicit programming, encompassing tasks like classification, regression, clustering, and more. Euclidean distance. A common distance metric used in numerical data. Calculated as the square root of the sum of squared differences between corresponding values in two data points. Scikit-learn. A popular Python library for machine learning, providing tools for data preprocessing, model training, and evaluation. Predictive modeling. KNN imputer can be used to fill in missing values in features that are important for training machine learning models. This improves the model's performance by providing more complete data for learning patterns. Data analysis. Imputing missing values allows you to perform exploratory data analysis and visualization without being hampered by incomplete data. This helps you gain insights and understand the relationships within the dataset. From sklearn, impute import KNN imputer. Imputer KNN imputer neighbors 5, weights uniform. Zimputed imputer, fit transform X.